then post-harvest management, consumption, waste management. My research group is working primarily on bioregenerative life support systems and how we can integrate plants into your bioregenerative life support system. How can you actually make this 100% circular? Then you start needing insects, more digestion chambers, and so on. But then you also come into these interesting aspects of it as well, like how is cooking in space? And then in terms of bioregenerative life support systems, so this is an interesting concept.
Welcome to the Omar Al-Aili podcast, your go-to podcast for exploring the diverse fields driving space exploration and technology. I'm your host, Omar Al-Aili, and today I'm thrilled to be joined by Tor Blomqvist, an agronomist and researcher at the German Aerospace Center, DLR, leading the frontier in space food production. Tor's pioneering work tackles how we grow, process, and sustain food off Earth, shaping the future of long-duration space missions to the Moon and Mars. Tor, welcome to the podcast. It's great to have you here today.
Thank you, Omar. It's great to be here too.
Okay, Tor, when we think about long journeys, like driving across a country, packing snacks is simple. But planning meals for multi-year missions to Mars, where there are no grocery stores and resupply depots, presents challenges on a completely different scale. Could you start by painting a picture for us? Why is establishing a reliable food production system the critical bottleneck for enabling a sustained human presence on the Moon and Mars?
Right. And this might be a long answer, actually. So, I mean, anywhere you go, right, you want to have things to do. Particularly, you start planning food and what to eat, right? Mm-hmm. And we've seen that in history as well. Like for exploration missions, food has always kind of been either an issue, actually, or something that, you have to plan about. What actually are you going to eat? And in the same way, like food production is the backbone of a functional society. And this is also something that we can see through history, but also, I mean, if you think about it, like we need food. And this has also become an interesting issue now in the current events of the world, where countries have started to kind of look into their independency of food production and to see like how independent are we actually? Would we survive if all of our trade routes got cut off? Can we actually produce everything in our own country that we need? So just to put that into a little perspective, but then when we start looking into space, we're going further away. And eventually we will not necessarily have the possibility of that much resupply. So this is, I mean, to start with too, now we're talking about a little bit further in the future, right? Because first, in near term, food is most likely going to be prepackaged, and to kind of follow that the diet that they already have. And I must say also that it's worth emphasizing that the people working at this or working with the current prepackaged space food work hard to kind of solve the challenges of making the food last longer, making it more appetizing, make it kind of retain nutrition also over that time. Because also the initial Mars missions, they're discussing if they need to like pre-position food, like send food up there before the astronauts get there. And so in that case, like food needs to last for at least 5 years. But looking further into the future, and this is something that, maybe 20, 30, 40 years from now, we're going to look into having more established outposts on the lunar surface and on the Martian surface. That research needs to essentially start now if we're going to succeed with that. That includes food. So we are looking into essentially the further away from low Earth orbit we go, so to the Moon and to Mars, so the further we push the frontier, essentially, the more we have to think about how are we actually going to supply these astronauts with food. It has becoming an increasingly important question, and even since the start of space food, right? Because people usually associate space food with these tubes and nutrient-dense cubes. I mean, it showed that, like even if short missions, like astronauts did not eat them, and just because they were quite boring. They either didn't taste good at all, or they were kind of like boring
Mm-hmm.
and or lack texture or anything like that. This is also why the space food people has put so much work into actually developing the prepackaged diet as much as they can.
Mm-hmm.
But it's something that we cannot forget now either. Because when we start looking into how we can produce food on the moon and for lunar outposts and habitats, um, and eventually on Mars, I mean, the primary question is essentially like how can that also taste good, right?
Your expertise uniquely combines agronomy, food science, and food production. For listeners who might associate agronomy purely with farming fields on Earth, could you unpack these terms and their parameters in the extreme context of space? So, how does the fundamental goal of growing plants, transforming them into safe, edible products, and managing the entire cycle sustainably, how does that change when you're dealing with microgravity, radiation, and absolute resource scarcity?
Right. So this is actually an interesting question. There are a lot of things that do change, but a lot of these things I also don't know because
Mhm,
they have simply not been researched. And
mhm,
I'll get more into that soon. So agronomy is essentially associated with terrestrial applications, field agriculture, and so on. There are plenty of different types of agronomists. I would be the one that more overlooks the food system as a whole,
mhm,
focusing more on like what happens post harvest, food quality, and taking that knowledge in and applying it into space where we have like an overall goal to create a decentralized food system. It's actually quite an interesting challenge. So you take all your knowledge that you have, and then you try to build something up in a totally blank space and see like how can we actually do this. What I noticed is that we need a lot more people like agronomists and so on that are from traditional terrestrial fields,
mhm,
because the same goes for like food tech and everything. It needs to become more interdisciplinary because a food system, for instance, comprises everything,
mhm,
and it's affected by cross scale interactions. Now we're essentially trying to create a new decentralized food system in space.
mhm,
We're thinking about how that could look like in the future.
mhm,
We have to take account into essentially the whole food system.
mhm,
And that does not just entail like a production technology.
mhm,
So, I mean, if you think about it, just growing plants is
mhm,
just one thing. It provides you with plants, but what are the other things that we can do with it or that we need to do with it?
mhm,
So we had to think across elements too. So the elements of a food system could be, for instance, like the primary production, the secondary production, the which is feed, and then post-harvest management, consumption, waste management. So that's how we easily can kind of divide the space food system into its different elements, just
mhm,
focusing on in situ production of food. So disregarding the prepackaged stuff,
mhm,
which will have a part in it as well. We also need to kind of uh, apply certain strategies to this, where we need to see like how do we actually get to our end goal. So how do we reach that outpost or small colony on Mars that has an independent food production? What do we
okay.
actually need for it? So then we start need to looking at how would that system look like? What are the feedback loops between everything, not
Mhm,
only for like material flows, but also the psychological feedback loops, the social aspect of it all.
mhm,
And how does that actually impact the other end of it? Because essentially you have these drivers for a food system that encompasses many things.
mhm,
But one of the major ones here would actually be the social parts or the social drivers, because it's a socio-ecological system essentially.
mhm.
Then again, we also need to plan like, could it be similar to what we do in Antarctica right now, for instance?
Okay.
Like, should we just ship food there, and they have freezers and everything in a simple
Mhm,
plant production module,
mhm,
and they're fine with that, and we can supply them each year with food, and there are about 10 people living there. That could happen, but it could also be the opposite. Then we need production technologies, we need post-harvest technologies, we need waste management technologies, and those all need to work together and function together. And it needs to, yeah, function as a whole system, essentially.
Okay, so we've seen fascinating images of astronauts harvesting lettuce on the International Space Station using systems like the Veggie. While inspiring, these are single use, small scale experiments. Can you give us a sense of the current state of the art? What types of technologies and food systems are currently being tested or deployed to tackle these challenges?
So we have a variety of them, and there are plenty of people developing like food technologies for space, and they each have their own challenges. I think that most people are focused on plants. Then we also have some that tries cultivated meat, for instance,
Hmm.
and we have some people looking into how to make food in bioreactors. So it's a little bit of everything, essentially.
Hmm.
But here again, you will probably need to think about the feasibility of these systems in the future as well. So, what you should really, really focus on is a palatable output, right? Like the
Hmm.
food actually needs to taste good. We're also looking into, like, when I'm scouting, the technologies that exists out there. It's usually interesting to see, like, can you actually make this work on Earth? Because if it works on Earth, it's highly likely that it will be applicable in
Hmm.
space at some time too.
Hmm.
Um,
Okay, so from your perspective, let's circle back a little bit before we move forward. What are the limitations of the prepackaged food astronauts mostly rely on?
so the limitations of that would be essentially retaining food quality, so
Hmm.
like the nutritional quality of the food over time,
Okay.
because we don't necessarily know what we're dealing with when it comes to space radiation or deep
Hmm.
space radiation, and how that kind of degrades its nutrients. And
Hmm.
as I was talking about earlier too, and how they're looking into pre-positioning food on Mars, for instance, they need to find a way how to store that food
Hmm.
and how to make it last for as long as they possibly can, how to increase the variety of it and the palatability. Because even if you take your favorite food, for instance, if you eat that for every day, you're going to get tired of it. It's not going to be your favorite food anymore.
Okay.
So I think those are the some of the major challenges that they have, and then you can go in more granular and also start talking about packaging materials and so on, which I would not be the right person to answer those questions.
Okay, no worries. Now, this leads to the concept of Earth independence. You're researching how to establish an independent bioeconomy off world and advocating for the centrality of food. What does that actually mean? Could you unpack this concept for us, please?
So first, establishing an independent bioeconomy. That would be establishing a well-functioning food system that runs in a way that a bioeconomy works. And the bioeconomy is a concept that not necessarily everyone gets right, but
Hmm.
think about it how you kind of utilize resources within your habitat. So you grow plants, plants has roots, you can't eat roots. They then get turned into or put in a digester, and then you can kind of reuse those nutrients that you still have in them because they're full of nutrients, right? That we can't eat.
Hmm.
That goes back into the plants, whereas you might get something else from that fermentation process, for instance, like biogas. There's also a lot of side stream management that you can do as well, and you can create packaging materials probably. Essentially, it needs to be like 100% circular.
Hmm.
And this is also when we start, it starts to escalate quickly. How can you actually make this 100% circular? Then you start needing insects, um, more digestion chambers to actually break down your waste and also to feed these other things as well. So that would be a bioeconomy. And then I was also you mentioned the centrality of food
Centrality
in
of.
our life.
Hmm.
And food is a central aspect of our life. Even if you don't like cooking or care about food that much, you
Hmm.
talk about it at least once or twice per day, actually. And food is cultural. It's emotional, and something that even like like you you get childhood memories from it sometimes just by eating something weird that you did in your childhood. It's also social. Like you sit down and you talk about things over at a dinner table. And this is something that we may take for granted here on Earth, actually. But when we get rid of that, you start to miss it more and more. And this is something we notice also when we look into like old polar expeditions and even space, when they've actually started thinking about this more and more and talk about it. So food is a central part of our lives, whether we want it or not. And it's not just for the nutrition and the sustenance. It's actually for our psychology to function. Food is that important. Me, for instance, I cannot live without good food. It's
Yeah, but you also have a background as a chef, also, right?
I do, yeah. So yeah, I might be partial, but like, yeah. No, I worked as a chef for a couple of years.
And how
Started when
does
I was
this translate
15.
for? Sorry.
I started when I was 15, then I was 18. I moved down to Paris and worked there for a couple of years, and then back to Stockholm.
So how does this influence the work you're doing now at the?
Well, I try to really push for the good food. Like
Mhm,
you can see that instantly sometimes when people talk about certain things.
mhm.
Um, for me, it's easy to see because I'm like, well, no one would eat that.
Okay.
And they're pushing it and pushing it. Like, this is good because it's so nutritious. But it's like, okay, you first of all, you forget about portion sizes.
Mhm,
Like, you can grow arugula is super nutritious, but you
mhm,
won't eat more than like a handful of it. And for that, like the nutrition doesn't make sense because
mhm,
it's so little. But also, I mean, plenty of other things that people create. You're like, well, this actually, I would never ever want to eat this because I don't care about how nutritious it is. And if it's safe, I don't want to eat it because it tastes bad. And I'm not going to be the only one there. And but then you also come into these interesting aspects of it as well, like how is cooking in space? We will probably have a galley at some point at at any lunar outpost. So have anyone started thinking about these things? Like, how do we actually cook the food? And that also food needs to be enjoyable. Like, that also comes into it, right? Like, think about it as like astronauts are not robots, they're human beings. So, whatever they do with their food production technology or how they need to supply themselves with food in the future, they need to be able to do that.
mhm.
Uh, the same as you when you come back from a long day at work and enjoy it because food needs to be enjoyable. The food should not be stressful.
Okay, let's now dive into the bioregenerative life support system, or the BLSS. Can you walk us through the key components? We often focus on the plants, but you mention microbes playing a crucial role in the waste processing and nutrient recovery. How do you engineer and balance this complex web of life, plants, microbes, humans, to achieve near perfect recycling or a closed loop?
So that's something that we cannot necessarily, or I can at least not necessarily answer just yet, but I can answer with other things that I know.
Hmm.
So or the challenges that we have ahead, right?
Hmm.
So for instance, when we start to recycling plant matter that we can, like inedible biomass, essentially.
Hmm.
We also have to make sure of certain things, like is it actually safe? When we design a plant habitat or like a habitat like this, food safety needs to be one of the primary goals, right? That we need to ensure food safety for everyone. Those processes they may change as well on the lunar surface, and like microorganisms have increased pathogenicity and microgravity, so probably something similar there in reduced gravity. They proliferate faster, so we need to research all of these things in lunar gravity. But then also we're getting into something new, right? We are
Hmm.
having a habitat with everything just mashed in there together, plants, bioreactors, everything is a mess of things.
Hmm.
And then we have astronauts, and astronauts are, again, human beings. So how can we actually ensure food safety along this whole process? How's the handling occurring of all these things with tired people working there that are exhausted from their everyday work? How can we, first of all, in those processes, like using example as recycling waste, right,
Mm-hmm.
to get back into our food production.
Mm-hmm.
How can we ensure that that's food safe? What are the processes that are actually that we need to do?
Mm-hmm.
And then you might not be able to do the same process all the time either, because you might not need the end product of that. And
Mm-hmm.
so you might have a backup system just for redundancy to have something else that you can do with the same matter or something, or you figure out a way how to store it and use it later, or you give it to insects, and but then you might have like way too much insects, so you need to do something else with that. Yeah, it kind of quickly escalates into plenty of technologies that are needed to actually make it purely circular.
Mm-hmm.
But as a start, I mean, we can't just implement everything at the same time at the moon.
Mm-hmm.
So we need to start somewhere. So we're going to start with small plant production modules to actually investigate like how does the plants grow on the moon?
Mm-hmm.
Are they safe to eat at all or
Mm-hmm.
not? What are the differences between that and low Earth orbit and Earth?
Mm-hmm.
And then from there, we can start talking about plant production modules when the crew size gets big enough that
Mm-hmm.
we can, and the duration and the frequency of the mission, so that we can actually use them, or that
Mm-hmm.
we have a need for them. And there we will continue on more and more research and science. Then we can also start seeing how that differs from our ground test demonstrators, which is
Mm-hmm.
essentially a replica, you could say, of the thing that will be on the moon, but we
Mm-hmm.
tested on Earth. And from there on, we will also see, you know, we'll start to investigate these processes, these circular processes, and so on. And then, in terms of bioregenerative life support systems, so it's an interesting concept. You use plants to take your carbon dioxide and make oxygen.
Mm-hmm.
And you get food out of it, but that's not the primary reason why we're growing plants, right? Like, we're growing plants to get food.
Mm-hmm.
The oxygen is just a bonus of it, and so far nothing that we can really rely on, right? We will have like a physiochemical life support system for a long time, most likely. So ECLS, and then we need to figure out how to integrate ECLS and BLSS into
Mm-hmm.
together. um,
Is this something you're working on, or the LR is working on,
So DR
investigating?
is working on BLSS, yes. So my research group is working primarily on bioregenerative life support systems and how we can integrate plants into a bioregenerative life support system. So we tested that in Antarctica for about five years, which was a really cool project. I was sadly not there, but half of my office were. They all
Okay.
seen penguins. I'm very jealous. Um,
Is it the Eden?
yeah, the Eden ISS, right? Yeah,
Eden
exactly.
ISS.
So that kind of like went on to become Eden Luna, that we're gonna integrate in Keln,
Mm-hmm.
in the Luna facility, which would be a super cool project where we can actually integrate that with astronauts and the flex hab that they have there. And then at the same time, we're working on the Lunar Agricultural Module Ground Test Demonstrator, as it's right now called, so LAM-GTD, together with the Canada Space Agency and many others, to actually create a ground test demonstrator of this, where we also have partial pressure and so on, so
Mm-hmm.
that we can investigate both how the life support system works, and also the plant growth parameters and all of that. So it's all about creating more and more data sets.
Yeah, exactly.
Yeah,
Exciting.
yeah, super exciting.
Tor, much of the public's focus is on the growing part, but your specific expertise also lies in the critical yet underexplored stage, which is the post-harvest management, as you mentioned earlier. Why is figuring out how to effectively store, preserve, and process the harvest after it's grown just as important for the success of a long mission like Mars or Moon?
I love this question. So first of all, there's plenty of things here to talk about. But first of all, food storage. What is the
Mhm.
first thing you do when you come home from the grocery store? Well, you put everything that needs to go in the fridge, right? And I always thought, like, why do we optimize the growing technologies and the production technologies so much if we're just going to end up throwing everything away after a week?
Mhm.
So we actually need to start investigating food storage. And what I've noticed is that when start looking into this subject as well, is like, well, this might not be as easy as we probably or as I thought initially.
Mm-hmm.
I might actually lead a whole research team on just that project. Essentially, we well, first of all, like we grow a bunch of food, right?
Mm-hmm.
And let's say a plant production module. So you will have a lot of output in that, and your production planning depends on so many varieties of factors. But you will still produce a lot of food. It's going to be food that's from also counting in the consumption rate of a normal person of vegetables. Like you're going to have a lot of leftovers after a week. So we need to somehow figure out how to store that food. So we can start with refrigerators, which is
Mm-hmm.
easy, but some certain food or certain vegetables and fruits gets cold damaged. And it's not necessarily always enough either, because you need to kind of stop some post-harvest physiological mechanisms in plants, like they continue to respire, transpire, they start living there, then start going through senescence. So it's essentially the aging and dying of the plant. So they continue to release heat and water, and they produce carbon dioxide. So it's kind of the opposite. They consume oxygen and they release carbon dioxide. And so this is what happens essentially when your plant go, or you bring home a cucumber, you leave it on the counter for a while, it goes soft eventually. It's losing water
Mm-hmm.
because of these processes. And then on top of that, you have microorganisms everywhere, and they are usually opportunistic. So, if the plant matter becomes a little bit soft, they're like, okay, now I can actually chew through this. So cold storage only lasts you for so long. But it might be a good start. And then we might be able to retrofit the storage with like controlled atmosphere storage capabilities, like you do nowadays, for instance, is that, or on Earth, is that you have a thing called controlled atmosphere storage. So
Mm-hmm.
you flush it with nitrogen, and you increase carbon dioxide levels, decrease oxygen, and then of course humidity. Um, and then you have ethylene scavengers. So ethylene is this ripening hormone that affects some plants, but not all plants. That
Mm-hmm.
also some plants release. Um, that it's either good or bad, depends on the concentration and the plants and so on. So you need a way to scavenge that as well, and that also becomes a critical factor. And then, of course, every plant is different, because why have a universal thing? So and there's plenty of other ways we can do this as well. We can
Mm-hmm.
have this thing called so actually it's interesting. Like when you're in the grocery store, you buy a piece of lettuce,
Mm-hmm.
and you have it in a packaging little box. Same thing with meats and stuff. That's not just a box with a film wrapped around it, or well, it is, but those films usually have like properties. So there's a certain diffusion rate of gases. They're usually flushed with, so they have a certain gas mixture in there. Sometimes oxygen scavengers in there. So it's highly technological packaging.
Mm-hmm.
So if we're gonna do food storage right on the moon, well, first of all, we'll need to figure out how is post-harvest physiology of fruits and vegetables in space. Well,
Mm-hmm.
we like on the lunar surface. How does the reduced gravity and deep space radiation affect these processes?
Mm-hmm.
And then also with this modified atmosphere packaging, for instance, the lack of convection inside of that packaging will definitely mess up some of that gas mixture.
Mm-hmm.
Um, and have an effect on the post-harvest physiology as well. And then the film properties itself is also probably most likely going to get affected somehow. But we need to research that and figure out how and what happens to also be able to assess what's the right method of storage, which we then again needs to also in the same time try in our ground test demonstrators. So it's a huge thing there, and it goes for not only plants. Like if we're gonna have cultivated meat, insects, all that needs food storage,
Okay.
and then you go in processing. So um, when you start talking about independence,
Mm-hmm.
this is far in the future, but like we need to plan for this now and do research on it now. But you start talking about independence, and so then you start to think about staple foods. So people talk about growing wheat and soybeans and potatoes and these kind of things.
Mm-hmm.
Well, we can do that, but what happens next? We need to make them edible. The same thing goes for insects. If we're going to produce them, you need to actually. Well, I mean, you can eat a living insect if you want, or just died one. So all of these things needs some type of post-harvest management. All things needs proper storage, regardless of temperature. There's more things involved in storage. Even
Hmm.
if it's ambient temperature, you need probably adjust the atmospheric conditions for it to. But then you also need to process them. So if you're going to grow soybeans or wheat, you need to kind of thresh those, which could easily be done by hand, but it's a dusty process.
Okay.
They need to dehull them, and you need to mill them in some way, and you need a kiln as well. For various reasons, depending on what you're growing. Right there, you need like two pieces of processing equipment, or three pieces actually. Then the kiln, which would be an oven with steaming functionalities. That just to actually process them enough to actually make them edible. So this goes for most things, or most staple crops. But then, yeah, you have tubers, like potatoes. Well, we need to not eat them raw, so um, I have done
Yeah.
that. It's not great, but you then you might not need heavy processing equipment, but you're looking into at least like how can we cook it? How do
Okay.
you boil something on the moon? And for anyone listening that is interested on like the problems with that, you can Google boiling water on the ISS to see how boiling actually works in microgravity, because we don't necessarily have any natural convections. So yeah, how do we cook food in space? And
Hmm.
there are some people that investigated that as well. From that little research that I did on that, realized that we need to do those experiments in space rather than in flight tests and stuff on Earth, because anything food essentially needs to come up to an equilibrium and to be done over time. So we need to an experiment that runs more than a couple of seconds. But yeah, no. So that's the importance, or the brief importance, of post-harvest management.
Okay, so this stage, the post-harvest management, which is storage and processing, is critical, but requires trade-offs. Maximizing longevity might compromise taste or nutrients, while preserving quality might demand precious energy for things like refrigeration you just talked about. From your vantage point, leading this effort, how do you reconcile these competing demands?
Well, so right now, there are certain things, because this is, a little bit in the future. I tend not to think that much about, monetary questions, or like how much does it cost and so on. But the energy question is absolutely a factor into it.
Hmm.
But they don't need to be that complicated. People
Okay.
usually think about these things as like heavy equipment that is super complicated and draws a lot of energy. But I mean, if you're going to mill wheat for six people, you can hand crank that.
Hmm.
And even if you have like a hand crank, you can put a screwdriver on that. I did that to my coffee mill actually, which is like a hand manual coffee mill. And
Hmm.
it fits a screwdriver. So um, it was fun. But there's many ways around this. So I actually don't necessarily think that. I mean, the refrigerator obviously is going to take up a lot of energy, but we
Hmm.
also need that. It's an essential thing if we're going to grow food. We need to store it, so it needs to be worth it somehow. And then
Hmm.
the engineers can figure out how to reduce that as much as possible. Same thing with space. So there are certain things that need to be optimized, but
Okay.
we're not necessarily there just yet. But for the processing part, yeah, we're having a lot of challenges, right?
Of
So,
course.
while you need something that is low in energy, that is big enough to handle what you grow, but small enough to actually be a considerable payload, and that also follows all of the standards when it comes to crew safety and off gassing and so on. Like if you're
Hmm.
gonna go mill wheat, it's gonna be if you've ever been in a mill, it's very dusty. They they don't even want you to have static electricity on you.
Okay.
So everything like needs to be contained in some way.
Hmm.
And I think like when the crew size is small enough, you can hand crank things and so on. But then you also need to think across temporal scales. So what happens? You don't necessarily want to, launch new equipment every now and then. So you want things to be a little bit more modular and evolvable, essentially. So you also need to think of that and design for it. How can we make something that could scale up, for instance, but then also need to be, it needs to be repairable as well, and modified and so on. While all of these things are worth thinking about, they're definitely there in the trade-off, but I think they can be engineered for, because we're not just going to apply whatever we have here on Earth. We're going to design new ones that fits our requirements.
Okay, so the requirement for food to remain safe, nutritious, and palatable for potentially 5 years seems staggering. What are the biggest enemies here? Is it microbial spoilage or the slow deterioration of vital nutrients like vitamin B1 and C? Or is it something else?
So, well, it depends what you're talking about. So, for instance, the prepackaged food, it would mostly be nutritional or nutrient degradation, right? So, that food needs to have the same amount of nutrients as the day it was launched to the day it comes back, essentially. So, the astronauts needs to be as awake and functioning from day 1 to day 500. And nutrients degrade over time, so the food loses quality. And this is, there's a lot of intrinsic factors that affect that, but there's also extrinsic, like, radiation affects it in so many ways. So that would be the primary concern for them, sure. But then as soon as, the astronauts open the food, you're going to introduce microbes. So it might be that that also becomes a problem eventually. But then when we talk about the food production systems, you're going to have both problems for sure. It depends on how much and what we produce. Do like a cucumber loses all of its nutritional value within a week in deep space radiation? I don't think so. But, we might also just do that research to get that done with, to see also like how much it does. Because then we can also maybe equip our food storage units, for instance, with enough shielding, but also they're going to be in the habitats and so on. But nevertheless, it's also something that needs to be researched. And then microbial control, that's also a challenge. What are the microbes we're actually dealing with? And so far, we're looking into pathogens, human pathogens. That are the typical ones, but we might also want to look for like post-harvest diseases and so on. And there are certain microorganisms that are not necessarily pathogenic, but might affect you in other ways. There's a lot of issues. The microbes are definitely like a huge part of it that we need to look more into if we're going to keep the food safe.
So beyond preservation, processing is key for variety. How do you envision taking staple crops grown in space and transforming them into different appealing meal components within the confines of a, let's say, trans-Martian spacecraft or a lunar habitat? Also, what type of crop do you see us choosing to take with us off Earth?
First I might say, like, on the Mars transit vehicles, for instance, we might just be looking into having a like small crop module just to get some fresh lettuce in there, but there won't be any major fruit production, I don't think. It's not until we actually are on the surface, and same thing with the moon too. But yeah, processing, as you know, like, you have your stove at home, right? Like, you can cook a variety of things with the same ingredients, and the same thing for processing. Like, just say oats, for instance, you can just do dehulled oats, make like oat rice, and you can press them and roll them, get oatmeal. You can do a lot of variety of things. You can make granola. Like, there's plenty of varieties that comes out from actually processing something. There's some challenges with that too. Like, we need to actually figure out what to grow. Well, we need everything, right? You need your micronutrients, but you also need your macronutrients, especially when we're talking about staple foods. eventually. Um, we need our calories, of course, or our energy. So aside from carbohydrates, we also need protein, right?
Mhm.
But fat, which is something that people forget about. How are we going to get fat up there? And that's also something that lasts the least. It oxidizes immediately if stored in the wrong conditions. And we forget about fat. Fat
Mhm.
is actually something that probably most of us have a deficiency of as well. So could we actually, or would it be worth growing something that could produce fat in space? So it would be cool to see if we could actually make like soybean oil or canola oil or things like this and make it like worth it, because you also need a lot of it to
Okay.
make a significant amount of oil. Um, but so that's a future challenge actually. How to get fat in our diet up there if we're going to have a independent production system. But aside from that, the crops that we're going to bring, I mean, we have plenty of candidates. NASA just released a technical report of the plants that they've grown on the ISS. They're like potential candidates, mostly pick and eat stuff.
Mhm.
But it's all going to come down to what the nutritionists say. Like, well, you should probably do these, but also, I mean, essentially, the astronauts won't grow what they won't eat.
Okay.
So it comes down to them, right? Like, you're not going to grow something you dislike. You hate tomatoes all over
Mhm.
like your group of 6 astronauts just hates tomatoes. You're not going to grow those tomatoes.
Okay.
So, and it might like some other type of lettuce that you grow more frequently.
Okay.
So that's definitely gonna play a role in it. So like we cannot control that much of what the astronauts eat in the end, because they are the ones in charge of their own diet,
Mhm.
essentially, in that case. But it's also important for them, right? Because they need to have some sort of sense of agency, so
Mhm.
they can actually choose what they want to eat. And that's also a bonus with having these growth systems, right? You can actually choose what you want to grow in some way. But as long as you have variety,
Mhm.
you're gonna be pretty fine with it. As staple foods, which are a bit harder because they take longer to grow and they require a little bit more time and energy and so on. That is a good question. Well, first, I mean, come back to the oil, right? We need fat, and then we can look into like what would actually make the most sense out of a nutrition or a nutrient perspective.
Mhm.
And for me, what I just think spontaneously is like oats. Oats is so good. It's so
Mhm.
healthy. It's tasty. You can do so much with it. Um, and then of course potatoes. Yeah, but I think we'll see. Like it still depends on the astronauts, right? And what we can actually grow.
Bringing it all together, Tor, as an agronomist who also deeply understands food science and food production systems, you bring the crucial gap between the plant growth chamber and the astronaut's plate. How does this post harvest thinking influence decisions right back at the start?
So for that, I think it's quite simple. Like we need to avoid bottlenecks
Mhm.
because you cannot have storage bottlenecks, because otherwise you would just spoil a lot of food, right? So you need to plan it a little bit better, maybe. Then eventually comes a time when we start looking more deeply into food storage and what
Mhm.
can be stored together and the atmospheric requirements of this produce. Then we need to start thinking of the production planning accordingly. Uh, so that would be the most simple answer to that question, I think.
Okay.
that
So, establishing these closed loop systems involves managing complex microbial systems and potentially using novel preservation or even genetic modification techniques. What are some of the key safety, regulatory, or even ethical considerations that need careful navigation as we develop those highly engineered food systems far from Earth?
Well, so a lot of these things have been used on Earth for a very long time, so we don't necessarily have issues with that. Like, I mean, we've been fermenting things for God knows how long, and it is now when we start looking into to see how like could we actually like cultivate meat somehow? Could we grow like single cell proteins? Um, and those have also been on around on Earth for a very long time. They're there in the grocery stores. Just that they have some issues, and that's palatability. They have the same on Earth too, and that's actually like a question for this sector as well. That especially deals with these alternative proteins is essentially palatability.
Okay.
But also, like, do you necessarily need to make fake meat? There's like the world of vegetables is so large, so there's so much variety. But in the end, I mean, like, you want to have something familiar. When at least I would like if I was deployed in space for a long time. So you want to eat something that's familiar to you. And then in the future too, like we don't necessarily know what the future holds. Like what might be trending now may not be a thing 50 years from now. And I mean, we see that through history. Like, imagine what you ate when you were a kid, for instance. There were certain food trends, like my parents in the 70s looking at their recipe books. Uh, it's, uh, it's giving me a good laugh sometimes. It's a lot of jello and stuff, like you see things coming, like gelatin comes into the world. You start to gelatinize everything. And so, you have these like food trends through history too, and it changes a lot. Then you have the things that stay. But so we never know for 50 years from now what people are going to eat actually, and how
Okay.
the normal diet will look like. But most likely in space, we're going to try to find and adapt technologies that work well here on Earth. But in the same time, we will also investigate novel things, see how they work, if they function in a situation like this, and try to also be some kind of accelerators for those
Okay.
technologies as well. Um,
So it's often argued that the extreme challenges of space push innovations that benefit us back here on Earth. How does the work on hyper efficient water use, energy saving LEDs, advanced food preservation, and closed loop resource management translate to improving terrestrial agriculture, food security in harsh climates, in crisis, even in urban farming?
so this is an interesting question because, I mean, as you say, like space technology has for decades improved the life on Earth, and um, like in pretty much every sector, especially in the medical sector and so
Hmm.
on. There's so much technology that's been developed in space that we now use here on Earth, and even the whole agricultural system is pretty much dependent on space. We use satellite technologies for everything. And I usually say also like people, when you say tractor to people, they imagine this old rusty thing, but that thing is more equipped than a spaceship.
Okay.
Tractors are ridiculously expensive for a reason. This is mostly thanks to space technology, actually, or a lot of it is. So, and now we start talking about food production in space. And we have to pretty much optimize everything, every surface. We have to economize with every single resource. So there's no doubt that there is knowledge that we will gain from developing decentralized food systems off planet they'll feed directly back into Earth. And I think a lot of times as well, the space sector might also be a bit naive and say, like, yeah, we're doing these things, and obviously they will benefit Earth, but that's not necessarily always true either.
Okay.
Because, like, even a thing like controlled environmental agriculture, right? Like, it's been around for centuries in a way,
Hmm.
but I think it like started for real and become commercialized after NASA first developed it or like modernized it, and then came up with a way to do vertically. But does that actually have an impact for in the food system? And how does that work across, in the social dimension of it?
Yeah.
And and so
Commercialization.
on. It's a question I don't have an answer to. So I
Hmm.
actually don't know, but it would be interesting to see. And this is something that I know that people are wondering and looking into actually, like what actual impact does this have?
Hmm.
So, and the same thing goes with everything else. So I actually think that if we are going to succeed with our goal of having a independent food production system off planet eventually, we need the knowledge, the years of knowledge from the terrestrial sector,
Hmm.
because they know this. They've researched food tech, ag tech, everything within the food system for centuries, and they have so much knowledge that we don't necessarily have. But we have a platform where we can accelerate that knowledge even further and innovate like crazy because of our constraints and our challenges. So I think that space can definitely provide a platform for this type of innovation, but we need the terrestrial people to take their things to us as well to actually make them work in space. And that way we can test new things, we can go crazy on stuff, and we can really try to actually think outside the box. So I think that in that way we can actually benefit each other. It's a two-way street. And then, of course, it always comes up humanitarian scenarios, because as soon as someone does something that they think can be done in space, they usually bring up the humanitarian crisis scenario, and it makes sense, right? Because they have the same problems that we do. They have the same challenges. It's like, well, a lot of this is like fortified foods that they rely on these supplements, these nutritional bars. And the problem is that it doesn't necessarily work because of how your body utilizes and takes up nutrients, right?
Hmm.
So just because you fortify something or give you pills, a vitamin C pill doesn't necessarily give you any vitamin C.
Okay.
Um, so they have this problem getting micronutrients to people. And to make it taste good. And we have exactly the same problem in space. How can we increase nutrition? How can we actually make people eat it? Because that's all that matters in the end. Like, it doesn't matter how much nutrients food contains. If you don't eat it, it just loses its function. So, and there's not always the largest population. If you don't talk about refugee camps, which are actually like small, like cities sometimes. You can
Hmm.
have one with like 800,000 people. It's insane. So for that, you need something more established. But this is an ongoing conversation that I've started with the World Food Program. Is how can we synchronize? And because what we do definitely feed into what you guys do, but you guys also have, they have the experience with actual implementation and to see how things work.
Hmm.
And they also need to work as well as different depending on what you want them from like a crisis scenario, for
Okay.
instance. You want to immediately supply food and fast. So that is one thing. But then, when you start thinking about how you rebuild communities, you want to do something more sustainable,
Hmm.
and sustainable from economical and social perspective. And then you might start thinking about not necessarily having your technology that costs $500,000 and produces food for half a person.
Okay.
But there is there's still a lot of overlaps. There's a lot of synergy. So what we need to do is essentially figure out how we can synchronize in between these, and how we can work together so that we, for instance, this like space food world can get the requirements from, say, the World Food Program, and then give that to the people developing space food technologies and say, this is actually dual use for your thing. It needs to be reconfigured according to these requirements, and then we can send them on the way to the World Food Program Innovation Accelerator, for instance,
Okay.
and then they can help the rest of the way.
Scientists usually are shy from making predictions and stuff like that. But if you can indulge me, looking ahead like 30 years to 2055 or 2060, what's your vision for an off-Earth settlements food production system, like a one on a lunar or a Martian settlement?
So usually to that question and answer, I have too much experience to give time estimates.
Hmm.
But but let's say It's a good question to answer, actually, because so many factors that play into this. And, it could just be, so you'd say like 2060, essentially.
Hmm.
So that way we have like, I would say we started exploring Mars. This is my hope. This is my absolutely most naive and possible or positive, optimistic uh, estimate of it all. So,
Hmm.
we've set foot on Mars. We have like maybe crew of six for like a year long exploration mission. The moon is more crowded, and um, we are starting to actually test more things on the moon. We have more of a established food production system, and it still works as a validation platform for Mars. So that's also very, very important to mention, is that there is a reason why we go to the moon before Mars, and that is
Hmm.
to test and validate everything that has to do with deep space, essentially. But then also, like, yeah, who knows what's going to happen? So let's say there's two scenarios to this. So scenario one is that we realize that we're going to continue as we do now. We're going to
Hmm.
have a full-on food production system, or like food system, with production, post-harvest, waste management, preparation, and so on. And we have plenty of food technologies established that works together in beautiful feedback loops.
Hmm.
And for that, we also need to be, you need to be quite a few people for that to actually be feasible. You cannot necessarily have a crew of six and have like
Hmm.
a whole food production system to take care of. That's not, it's not necessarily feasible. So, there's going to be actually like, 50 people or something there for that to happen, at least. But the scenario two is it's just for some science and exploration. So you have a similar scenario to what we have in Antarctica, or currently ISS, and that would be then like we figured out a way how to more cheaply send stuff to the moon,
Hmm.
and so you could launch freezers
Hmm.
and then just like launch a bunch of frozen foods, have some basic plant production capabilities, and have exactly the same kind of resupply scheme that they do for polar researchers.
Hmm.
And that would definitely be a possibility, and that it could definitely turn into that. But we need to plan for the other scenario too.
Okay.
Like we're also started talking about the lunar economy, and so it might be that while the agencies are moving the frontier forward, it leaves place for the commercial sector.
Hmm.
That also needs to be part from the beginning, especially within food. This is nothing
Hmm.
that one agency or one company will ever do. It's going to be a lot of entities working together all over the world throughout years. Um, but, anyways, for exploration, tourism, and all kinds of mining industries, whatnot, you're you might you might have a lot of commercial entities being there doing stuff, and this also, because this is something that won't happen in Antarctica because it's very, very protected, for a good reason. But we don't necessarily have that problem on the moon, from what I know of, at least. You need to space lore to see that, actually. But yeah, we could see this whole industry coming up with all kinds of stuff. Um, and for that, we need infrastructure.
Okay.
And for that, we also need to have more food production. But it's going to also be across like different nations being there as well. So it's also a good question. Like you might have, I don't know, a habitat from Europe and US of like 20 astronauts.
Hmm.
But then, neighboring that, you have the African Space Agency doing stuff. And
Hmm.
then you have like JAXA doing something else 50 meters away. Do you share food production systems, or do you each have your own? Or these are also questions that kind of come up,
Interesting questions. Yeah.
for sure. Because like in a settlement of like, I don't know, 150 people, like you don't necessarily all need to produce your own food. You can make it into your community.
Okay. Interesting. So like you have been advocating in this episode, this field is incredibly interdisciplinary, blending biology, earth agriculture, engineering, chemistry, and even psychology. For the students and professionals listening, perhaps architects designing habitats, engineers building life support, or biologists studying extremophiles. For those who are now fascinated by the challenges of space food systems, what advice would you give them? What skills or perspectives are most valuable for contributing to this field?
I would say if you study something that has like a terrestrial application from the start,
Hmm.
take that knowledge, learn everything that you can, and then you try to apply that into space. And you don't necessarily need to learn space engineering for that. That's something that you can learn and not try to implement into your own discipline afterwards.
Hmm.
And then you find what you think is interesting. And space world, especially space food, it's so open. We don't nearly have enough people researching it or developing things for it.
Hmm.
It needs more people. It needs more disciplines. And even people look at like studying economy. Actually, it's not only natural sciences or engineering. It's psychology. It's the social aspects of it. It's also health, but also like economical factors. Because this is, I mean, we talked about it, right? This is something that is we're looking into the future. So how can we
Hmm.
actually? But we need to start doing that research now. What's the economical aspect of that, especially for like researchers and small businesses, and because you also need to make money in some way. But anyways, yeah, find your interest, and then regardless of how stupid people tell you that you are, because I went through exactly the same thing. I was like, hey, I want to do space food. My university was laughing at me.
Okay.
Um, and yeah, I went home and did it anyways. Yeah, just try everything to get there and reach out to people. Like I think this is the question or the thing that people don't do. They always think about this thing. Like I would want to do this, but okay, have you contacted anyone? Like no, I don't want to.
Hmm.
And I mean, when I started, I emailed everyone. It feels
Yeah.
like, and I mean, they all answered, and that's just email people, contact people, see if they have something for you. The hardest thing I think in our field is that the funding is quite limited. If we had more funding, we would definitely employ more people.
Hmm.
So at the same time, keep your eye open for scholarships, because you might want to or need to actually go into more research than more a job role.
Okay.
But it depends. But follow follow your instinct and what you want to do, and do it, and contact people and build connections.
True. I can attest to that. If you don't ask, you'll never get an answer.
Exactly.
So yeah. So finally, Tor, a quick question: is there any particular science fiction book or film that inspires you or resonates with you?
I don't think I've ever opened a science fiction book in my whole life. I am a romantic.
Okay.
Right now, I read Mary Shelley's The Last Man, which actually could be somewhat of a science fiction because it's.
Okay.
But uh, but yeah, it's more films actually.
Okay.
Um,
Like what?
because I've always been a Star Wars fan, which is a
Hmm.
problem in my office where everyone likes Star Trek.
Okay. So
Yeah.
before we wrap up, is there anything else you'd like to share with our audience? Any announcements?
So any announcements? The only thing I can share now, but like, and because Ralph also did this, so me and Ralph work together, and it's to keep your eyes and ears open because soon there will be a thing called the Space Food Consortium,
Hmm.
and hopefully we will make a lot of impact and also help people with any space food related questions or things. So that would be the very tiny announcement of that
Great.
so far.
Yeah, I'm
Um,
excited to learn more about that. Ralph told me
mm.
about it. Okay. Tor, Thank you so much for sharing your expertise and insights with us today.
Well, thank you, Omar. It's been a
And to
pleasure.
our listeners, join us next time on the Omar Aleli podcast as we continue to explore the science, technology, and engineering that advances space exploration. Until then, keep exploring.